So in this question, a plastic membrane which is 0.25 mm thick and it has hydrogen gas maintained in it at a pressure of 2.5 bar and 1 bar on the opposite side. So this membrane, obviously there will be two sides for this membrane, and 1 bar this hydrogen gas is maintained at 2.5 bar, while the other end it is a 1 bar. And also the diffusion coefficient D of the hydrogen gas in the plastic is given as 8.5 into 10 raised to minus 8 meters square per second. And the solubility of the hydrogen gas is also given in the membrane, that is 1.5 into 10 raised to minus 3 kilogram mole per meter cube bar. Okay, under uniform temperature condition, so we are considering a uniform temperature case. That means not a variable temperature case. So we are considering an uniform temperature condition. What they asked is to find the molar and mass diffusion flux of hydrogen through the membrane. So we have to find the molar diffusion flux and mass diffusion flux. So, so first writing the given condition, we have thickness, diffusion coefficient, solubility. So these all are given the question. And this is a simple drawing. How does this membrane look like? How this plastic membrane and hydrogen gas diffuses into this membrane, and this two part of the membrane is maintained at two different pressure. One end is 2.5 bar, another end is 1 bar. So what they asked is to find the diffusion, sorry, molar diffusion flux and mass diffusion flux. So this is the equation for molar diffusion flux. So I'm calling the molar diffusion flux as Na, which is dAB into CH1 minus CH2 by L. So DAB we know it's a diffusion coefficient, that here it is hydrogen gas, so it will be the diffusion coefficient of hydrogen gas. So dA into I have rewritten and for better clarification, general equation was DAB. Here I am writing it as a dA. So dA into CH1 minus CH2 by L. So CH1 and CH2 are the concentration of hydrogen at the two sides of the membrane. Okay. So I'm calling this top part. I mean, like the place where the 2.5 bar, I'm calling the region to be 1. Another end where 1 bar pressure is maintained to be 2. So obviously this CH1 and CH2 will be the concentration of hydrogen at the 2.5 bar region, and CH2 will be at the 1 bar region. So how do you find the concentration of hydrogen? If you look, they have given the question, the solubility is given in the question. Solubility is needed to find the concentration. Solubility, not solubility alone. We need both solubility and pressure not to find the concentration. This is a relation between, I mean, concentration, solubility, and pressure. So, not find concentration, it is the product of solubility and pressure. So, if I need to find the concentration at this point, I mean, at the first region, all I have to do is just multiply the solubility of the hydrogen into pressure at this point. The solubility of the hydrogen will be same at both the phases. So it's a constant value. This is given the question. The only change is the pressure. So CH1 is the top part, so I have to multiply the pressure value there. There is no need to conversion because solubility equation is in kilogram mole per meter cube bar. We need to get the concentration unit as kilogram per mole per meter cube. So we have to keep the unit of pressure in bar itself. There is no need to change. Similarly, we can find the concentration at the part 2, that means at the 1 bar region. Okay, so we have both the CH1 and CH2. Now I can substitute in this equation to find the molar diffusion flux. So, okay, so molar diffusion flux will be around 6.8 into 10 raised to minus 10 kilogram mole per meter square second. So I have now find out molar diffusion flux. They also asked to find the mass diffusion flux. So how do you find mass diffusion flux? So for not to find mass diffusion flux, there's a relation between the molar diffusion flux and mass diffusion flux. The ratio of mass diffusion flux to molar diffusion flux is a molecular weight of the I mean whatever gas we are using. So here we have hydrogen. So obviously the mass diffusion flux to the molar diffusion flux is the molecular weight of hydrogen. Okay. What we need to find is to find the mass diffusion flux. So all I have to do is just multiply the molar diffusion flux that we have just find out with the molecular weight of the hydrogen. So we know the molecular weight of hydrogen is 2. So now we got mass diffusion flux. I call the mass diffusion flux as small j. You can call it by any letter. Only thing you have to check is to check whether the equation is correct. It doesn't matter what unit you're using or related to represent it. So the mass diffusion flux will be 1.36 into 10 raised to minus 9 kilogram per meters per second. Okay, so uh, we have to by heart certain relation. That's the only way to solve this problem. First of all, you need to know this relation. I mean concentration, solubility, and pressure, and the equation of molar diffusion flux. Okay, so this is a way to solve this type of problem. Thank you.